Yeah, I was asked to talk about AI today in a way that I convey my thoughts about it. This is one of the hot topics nowadays everywhere in the world. And when talking to Ganesh about what kind of presentation should I make today for you, the idea was that first I talk about some basic concepts and facts, and just survey some interesting subfields of AI maybe, and then talk about a bit more advanced concepts so that we stay kind of contemporary right now. So this is it. And let me just go to this first slide here. If someone asks you if this is AI, please say no, this is not AI, okay? If someone asks you if this is AI, this is not AI either. And this is not AI either, definitely. These three slides, they are science fiction. They are not artificial intelligence. This is just science fiction. So what is AI today? There are three broad categories of AI. And I think that today we are still somewhere here. I hope you can see my mouse pointer here. So we are here on the left-hand side. We still do a lot of machine learning, which is one of the most interesting topics in AI and one of the most popular ones. That's called the narrow artificial intelligence, or artificial narrow intelligence. And most of research industry products and everything in AI technology is related to this. Then in the middle, we have this concept of artificial general intelligence, which means that we should strive to produce computers that can do all tasks that humans can do at the same level. Well, I don't know about that. Maybe some traces of AGI, artificial general intelligence, are possible right now, but I think we still have to wait a lot before we get to the AGI level. And then on the far right, there is this artificial superintelligence, which is the idea of having a supercomputer that can do all things that humans can do, but much better in a much more powerful way, to actually just be smarter and more capable than humans. I think this is still in the realm of science fiction. Whether this one in the middle is, well, so-so, I don't know. I think we have to wait. Okay. In reality, AI, that's a lot of things. Some of them described here and depicted here. AI with a question mark, because I don't know if this is all what we call artificial intelligence, because nobody knows what intelligence is. Not even philosophers, neurologists, psychologists, they are not quite sure about intelligence, human intelligence is. But okay, we still have a good understanding of the concept of intelligence, just intuitively, although we cannot define it. And to that very complex concept belong these things that I depicted here on the slide. If you look at this left-hand column here, this is the foundations, I would say. We all do, like humans, as humans, we all do intelligent search. We all have some knowledge represented in our heads, knowledge about the world around us. So we can reason about that world. We can solve problems, and then plan our actions and schedule them in time and so on. So this is what is the foundation of intelligence, and of course of artificial intelligence. What artificial intelligence offers us are a lot of algorithms and theories and mechanisms to represent and run this part of intelligent behavior. This part of intelligent behavior represented in computers now is not at the human level. However, this is what these are things for which we do have algorithms that do well, good or not that good in some cases, but we know how to approach this. Here in the middle part, in the middle column, we have some higher or a little higher level concepts of intelligence that are based on these elementary level concepts here, like pattern recognition. If you, for example, take a look at the ocean waves, you will recognize patterns in these waves because all waves follow the common pattern. Although no wave is exactly the same as the other one, but they follow the common pattern. In machine learning, we are trying to reproduce human capability of learning. So we learn from examples, we learn from experience, we learn from textbooks, we learn from video information, and we are improving our knowledge. Machine learning is a huge part of artificial intelligence that's dedicated to learning. One of the most prominent mechanisms for learning in artificial intelligence are neural networks. I'll come later to this in more details, but they are inspired by the neurons in the human brain and the synapses, which are connections between neurons. And applied to some practical cases, neural networks are in the foundation of speech recognition mechanism, in natural language processing, vision and object detection and image recognition, things like that. Then there are other things here on the right. In artificial intelligence, we very often talk about agents. There is just again mimicking human society and situation in our lives. For example, there are agents for selling real estates. There are agents for representing other people, and so on. So agents are those entities, if you want, in AI that do specific narrow jobs. Robotics, you can take robots as agents as well. Robotics is a huge part of artificial intelligence that deals with robots, and we all know how powerful they can be. Then we have fuzzy systems. Fuzzy meaning that we don't have exact concepts in much of our in our processing in our brains. For example, if you say that today is a rainy day in Belgrade here in Serbia, what does it mean rainy? How much rain? Is it heavy rain? Then again, if it's a heavy rain, what does it mean heavy? How heavy? And so on. So these concepts are called fuzzy concepts, and there is fuzzy reasoning, there are fuzzy systems, and so on, which are completely innate to us as humans. But then again, in computers, you have to represent these concepts and somehow produce systems that are based on these concepts. Genetic algorithms, again, a huge part of artificial intelligence that follows the idea of things evolving in our heads, in our intelligence, in the nature as well. There are populations of, say, microorganisms that evolve over time. Then the next generation is maybe more sensitive or more sturdy or whatever, but they evolve over time. And so some things happen in our heads. Swarm intelligence is yet another very interesting part of artificial intelligence, where we're trying to mimic the behavior of, say, colonies of ants, or just colonies of bees and organisms like that, that exhibit intelligent behavior only when they are together with a lot of other representatives of their species. And then fractals, like take a cauliflower, and then the whole cauliflower looks pretty much the same as just one little part of the cauliflower. And if you take a little part of the cauliflower and look just closely to its parts, each part looks again pretty much the same as the bigger parts, and so on. These are fractals. All of these things, and then again, many more. Take a look at this ellipse here. Many more things. They simply just there are parts of our human intelligence. And then artificial intelligence is a branch of computer science that's trying to somehow develop programs that do things like this, and develop systems that help people automate their jobs and do something for fun, if you want, in the way that we call intelligent. Now, technology is what comes from these developments in the theory of AI. We all know about self-driving cars and self-driving vehicles, about drones. We all know about machine learning and deep learning, things based on neural networks that, for example, are in the foundation of ChatGPT and other large language models. They are very popular now. We all use them. But this is the technology that supports them. That technology relies on the general concept of pattern recognition. For example, in natural language processing, we recognize patterns in spoken language, and that's how it works. Then we develop some technology and products like chatbots based on all of these parts of technology that support all that. And they are all, again, based on the theory and practices of AI in general. Here on the left-hand side, we have some specific and very useful applications that are not really mainstream at the moment, maybe, but they are really very useful, like autonomous surgical robots that can access parts of human body that surgeons cannot access easily. Or maybe we have some robots that are operated from the cloud. Maybe we can also have some neuromorphic computing and so on. Again, not mainstream yet, but useful technology that is proven and does very, very nice things. And maybe on this lower left part of this technology landscape, we have things that are in the experimental phase right now, like in the gaming industry, we have thought-controlled gaming. We also have the idea of real-time universal translation. For example, I could have given this talk in my mother tongue right now, and with this technology, if it was available, you would be able to follow it in Hindi or in English or whatever other language. Again, this is not yet possible completely, but still we are on the path to reach it one day. You probably heard of virtual companions. For example, in Japan, elderly people have their companion robots that not only do house chore for them, but they can talk to them, they can entertain them, and so on. Okay, this is technology. if we put technology and theory and developments together, you see this image here, which is the current landscape of AI, not covering everything, but covering pretty much a lot of popular things in AI nowadays. This image here is one of those that I think should be the starting one for everyone that likes AI and that wants to understand the depth and breadth of AI at the moment. This is very important to stress, at the moment. So, for example, at the moment, we have neural networks, a lot of them, and a lot of configurations of neural networks, some of them belonging to deep learning. And we should understand that deep learning is part of neural networks, which in turn are part of machine learning. Machine learning is part of artificial intelligence. Each of these kind of levels or tiers of AI in itself a huge field. So this is a really huge field, AI, overlapping with some other fields, but it is important to understand that AI is not just machine learning and deep learning. No, it is really completely different. It's a huge field. This is not true. This is the image that you see all over the internet, but this is not true because it shows you or implies a wrong idea that everything is just that. No, 4 years ago, I wrote a paper in which I argued that at least let's put explicitly robotics and natural language processing to just show people that AI has many other things. Although, yes, NLP and robotics, they are really connected to machine learning and deep learning. But again, they are subfields of AI in themselves. Nowadays, I think this is much more true as an image representing what we have in AI. Because we have these foundation models that dominate everything in AI nowadays. We have a lot of robotics. They almost obscure the other things in AI, but remember this gray circle here and this yellow one here. They are in the foundation of everything. It's impossible to have large language models or large visual models and everything without having machine learning, deep learning, and knowledge representation and other things that we have in AI. Okay. Now, I'm showing you this book cover. For those who don't come from the field of AI, this is currently the most popular textbook on AI worldwide. And not only currently, it's very popular for more than 20 years. So Stuart Russell, Peter Norvig, they published this first edition more than 20 years ago. This is the image of the fourth edition. And this is a textbook that covers almost the entire field. I'm saying almost because it is difficult to claim that it covers everything, since the field is evolving rapidly. This book really covers topics, but it has one deficiency or weakness, if I may put it so. It is a very thick volume. It's more than 1,000 pages. And people hate reading textbooks that are 1,000 plus pages long. So I have to say openly that I read the first edition cover to cover, all of 1,000 pages. From the later editions, I'm reading only chapters that Stuart Russell and Peter Norvig are adding to the old ones. But this is important because the old ones are related to technology, to fundamentals, and the new ones are just the layers and the tiers coming up from the fundamentals. So if you care about learning what AI really is, go ahead, read Russell and Norvig. That's my message. By the way, this like a list of important topics in AI, this comes from Russell and Norvig. This is not something that I invented or just conceptualized. These are all things present in this textbook. Now, what is AI? Nobody knows because we don't know what intelligence, human intelligence is. But we can put up some descriptions just to bring the topic closer to common people. And I like this quote that I copy from one of Mark Andreessen's papers, where he puts really directly the fact that AI is essentially a lot of mathematics, a lot of statistics, a lot of computer programming, and in the end we get computer programs. So AI are computer programs that we can feed with some input data that produces a certain output like any other computer program. However, it is designed in a way that looks intelligent very often to many people. And there is no mystery, no mystifying AI. AI is computer programming based on a lot of really interesting and powerful mathematics and a lot of statistics. That's what I believe is one of the closest description of what AI really is. I'm showing you now a slide based on a pretty famous paper coming from a pretty famous journal. I really strongly disagree with this image here. The idea, the general idea is to show you that artificial intelligence is overlapping with many other fields. But this diagram here is something that I really disagree with because it creates a wrong impression that, for example, AI has nothing to do with databases, that AI has nothing to do with statistics, which is wrong. It's fundamentally wrong, okay? So please allow me to say that this pretty well-known diagram about overlapping of AI with other fields is something that should be taken with care because it shows implicitly some facts that don't hold in the real world. On the contrary, AI is based a lot on statistics. Statistics is based a lot on data. Statistics actually uses data coming from databases. And statistics is in the heart of machine learning and neural networks and deep neural networks and large language models and everything else that we know today. But this image is showing us that they are not really Excuse me? Okay. So, what are we facing nowadays? We all know, everybody's talking about AI today. Everybody, just kids in school, they play with their phones and just use AI as a buzzword. Look, this is AI, let's play some AI and so on. Even not only adults, even governments of many countries, they are concerned because AI is the technology that develops rapidly and it can do a lot of nice things. It can also do a lot of terrible things. So governments are concerned. In many countries, governments are producing like strategies of development of AI and so on. But there are topics in reality that are not that much spoken about. Like, for example, what is the cost of developing AI? This is a very important question because developing AI based on a lot of data, a lot of statistics, and so on requires powerful computers. How much do they cost? How much energy do they consume? This is not that much spoken about openly. Yes, we know some people speak about it, but not that much. We are all impressed by using large language models, but how they are produced, how they, or maybe should I put it, what are the computers that they run on, and so on. Then again, somebody will tell you, yes, nowadays I can have a large language model running on my PC, on my laptop, even on my phone. Yes, there are large language models like that. But in order to train large language models to do what they do, what do we need? We need very, very powerful computers that use a lot of energy. And those computer chips that are built into these computers, they are very costly to produce and so on. So we have to be aware of that. Then, since this is becoming very, very popular, how many people do we have nowadays that do AI in a professional way? I have to say something, and this is something that I think we should all be very careful about. Everybody will tell you that they are doing AI, but to what extent, and do they understand what they are doing? I'm not quite sure about everybody. Many people will happily say that they are doing their jobs with the help of AI, but do they understand what it means? Everybody, some people will say that they are developing AI systems, but are they aware of what AI means? I'm not really sure. We should have more really qualified professionals to claim openly that they are doing AI. Again, colloquially, when we say AI, we mean some nice technology that we do to automate our jobs, so that we sometimes do for fun and so on. It's very interesting, very challenging and so on, but that's a colloquial meaning used by the majority of people. Again, technically, it's a lot of mathematics, a lot of computer programming, a lot of statistics, and we develop systems based on these statistics, mathematics, and computer programming. That's a technical and technological part. However, philosophically, it's very interesting. Again, we don't know what intelligence is, human intelligence is, but still, many people are using the term AI as an entity in their talks, in their speeches. For example, if we talk of AI as an entity, we can say, "Hey, do we do it with the help of AI?" When we say a phrase like that, we often imply an entity that we call AI. True, AI based on computer programs, they do have memory, they do have some reasoning capabilities and so on. But again, they don't have feelings, they don't have emotions, these entities, okay? They cannot do things intentionally. They don't have consciousness. They cannot think or comprehend things in terms and to the extent that humans can. Then some interesting questions, philosophical questions appear here. For example, can AI, taken as an entity, be a legal entity? Can I talk to AI as my, say, lawyer? Can I talk to AI as my teacher? That's very philosophically very interesting. Or since you all come from a university, can AI be an author of a research paper? You all know that people use ChatGPT and other large language models to help them produce research papers. But is it AI, or is it humans, or do humans do it in an intelligent way, just deploying that technology? There was an interesting paper published in a journal 2 years ago where they put ChatGPT as a co-author of a research paper. So because a large chunk of that paper was done by ChatGPT. Can, for example, AI taken as an entity be a manager of a company, or maybe a commanding officer in an army? Well, these are open questions, and they provoke different thoughts and different discussions. So we should be aware of all that. And then we come to generative AI, which brings up the question of credibility, trustworthiness, and so on. So generative AI, that's a really huge technology that can create text, data, videos, images, and so on. And to this end, I have to show you Sora. And for that, I have to stop presenting this and go to the presentation mode again. So please excuse me. Now I have to stop presenting for a second because otherwise I can't present you Sora. All right. Maybe like this. I won't stop presenting right now. Maybe I should. How to do this? How to go back to this? Just a minute. No, I'll stop presenting, stop sharing just for a minute. Then I'll click Sora here. Okay, here I am, but then I'll start presenting again, but from another window. Okay. This one. Now, you're looking at a website coming from OpenAI, same company that produces ChatGPT and DALL-E and many other useful technology. And this is Sora that appeared like 6 months ago. It is a generative AI program that produces videos. Let me illustrate. Take a look at this video here. Looks very realistic and shows details that are artificially created. This is generative AI at its best. Look at the details. Look at the reflections of these puddles in the street after the rain. Look at the reflections of this lady's sunglasses here. Look at the shadows, for example, because if you take a look at her purse, if it is just showing the front part, it's different than showing the rear part because of the shadows. Look at the shadows reflected in her sunglasses and so on. These are the parts that have not been until recently. Okay, stop sharing again. Going back to the presentation, and I'll show you another video which belongs to something that is not that good. I mean, it's good, but it can be very dangerous. Okay, share again. And let's go to this one here. Yes, and share. Okay, you are now looking.
And you've done in a way that none of those failures of the past would recur because just the physics of how it's built.
This is deepfake example of what is possible with powerful.
And since you cannot hear the sound here, in this deepfake, which is really a fake video, there is a very convincing video of Bill Gates talking about something. You cannot hear what he's talking about, but he's saying, this is a deep fake video of me that was produced within 74 hours and so on. So it's a very short
computer and editing. It took around 72 hours to create this example from scratch using extremely
AI. Okay, why is this so dangerous and if you want, well, perilous to further development? Because you can do very abusive things with this. You can create fake data, you can create fake images, you can create fake everything. And because of that, let me stop sharing again, go back here, then share again. Excuse me for this, but this is when technology fails us sometimes. Okay, share again. Okay, due to this, we cannot trust everything that generative AI does for us. We cannot trust ChatGPT, we cannot trust videos, we cannot trust all images. For example, Nature, the most widely known scientific journal, bans creating videos and images and so on, and publishing papers in the Nature journal with AI-generated images. But then again, can AI review a research paper? That's very interesting as a question, because can I send a paper to a large language model and instruct it to review my paper? Yes, I can. But this is not naturally necessarily a bad option, because you can say, hey, but this is AI. It cannot be that critical as the human experts and so on. Yes, true, but it can suggest ideas about how to improve your paper. It can suggest ideas that you don't want to accept, but it can help you just reflect on these ideas. And then you come up with your own human intelligence to other ideas inspired by AI ideas that can help you improve your paper. Human experts, on the other hand, human reviewers are full of bias. They are not available very often, so you have delays in reviewing your papers. And also, you have some other really interesting capabilities of AI in reviewing research papers. AI can help you run those programs and data that the paper is based on, so you can have a verification of the results produced by humans, but then AI can do that verification. That's very interesting. So it's not clear-cut. This can be very dangerous. Somebody calls you, you hear the voice of your child, and that child is crying for help. So, hey, daddy, or hey, mom, send me please $500. I need I'm stuck in the airport. I need to buy another airlines ticket. But no, this is just the voice of your child, and you really cannot trust that, because they won't they are frauds, that they just want your money and things like that. Are you sure that you can take an image from the internet? Is it legal? Yeah, well, many large visual models are trained on pictures from the internet. Is it legal or not? It's an open question. One other thing, very important, there are many stakeholders of AI. All end users want their jobs improved, or they want AI to help them. They want answers from AI and so on. Developers develop that technology because it is really currently very popular. Companies, they want to sell that technology. Researchers are always interested in developing new algorithms, new approaches, and so on. Many organizations, including government organizations, they are concerned with AI because it is rapidly developing and it is exploding, actually. What about education? To what extent do we teach, or should we teach AI, and in what way? All in all, I'm saying that the society at large is actually one of the stakeholders of AI. But make no mistake, many people will try to sell you AI or to sell you something else which is not AI. If we are not qualified enough, we have our FOMO, fear of missing out, and we can become victims of these touts that are just trying to sell you something. Can robots replace managers? That's a very interesting philosophical questions that they are using in marketing. But do we trust robots as much as we trust human managers, and so on? Let me show you something else. In the recent, say, 12, 15 or so months, most innovation comes from industry, from companies related to machine learning and AI in general. Not that much from academia, which is very interesting. Until 2 years ago, it was completely the opposite. Also, most foundational models, like large language models, come from industry. Remember, Meta, OpenAI, Google, Amazon, and so on, they are companies. Most of these models come from companies, not from academia. Last but not least, China is leading innovation and patents in AI, really beating United States by the factor of 3. And beating European Union by the factor of 30, which is very indicative. So we have to be aware of these facts. Will AI, taken as an entity or as machines, will it take our jobs? I don't know. It will replace some of our jobs. It is already replacing some of our jobs. Remember driverless cars. Remember things like robots working in factories and so on. Yes, they have replaced humans to that end. But then again, I believe that there will be new jobs. They are opening, many new jobs are opening, so we as humans simply have to switch to other jobs. There will be, in my opinion, much more new jobs than humans available to take them. An interesting sub-question here is about automated programming, automated by AI. And many people say, hey, look, AI can create a program for me. I will just have to sit and watch. And what about those programmers and software engineers? What do they do now? I think this is a huge misconception, because they will always have job in my view, because they have to instruct AI tools what to do. They have to double check if the code produced by AI is okay. They will have to thoroughly test that code produced by AI and so on. There is this cartoon here showing what the reality is now. this is a joke here, but I think it's still rooted in reality. Look, we are now really bombed from the internet by courses that teach us how to use AI to create code. Yes, true, but we are also bombed by advertising of courses that teach us how to do AI programming, we as humans. And it's a race. Once we learn how to code some advanced programs, there will be AI that will learn how to do that as well. But there will still be humans who will have to double check that and so on. In education, I think we have to be very careful because things are developing at a light speed now. Things that were very popular in education until a couple of years ago may become obsolete very soon. Schools have to develop new curricula, and schools are developing, luckily, their new curricula. I want to stress that there are whole study programs in advanced countries developed now to just be dedicated to AI and nothing else, which I think is good. But then on the other hand, in those study programs, I think we have some foundations, some general knowledge, and so on. Artificial general intelligence, those AI agents that can perform all the tasks that human can with the same level of capabilities, or maybe even better. I think we are far from that already, although some people believe that large language models are the first step towards artificial general intelligence. If you look carefully in those digital libraries, you will find papers written by really reputable scientists about that. I don't know about that yet. I myself have a cautious opinion of large language models, using them and their capabilities. I admire them; they are wonderful, but they should be taken with care, in my view. One thing we really have to be careful about: please do not confuse AI with science fiction. Because this can lead to really false understanding of what AI is, of what that technology can or cannot do. Unfortunately, a lot of popular press is telling us that AI will destroy human race, will come here as some terminators and conquer all of us and so on. Please do not trust that. This is not the case. What is a fact, and it was wonderfully put by Chris Panning from the Stanford University, is that a lot of professionals in AI are just sitting there quietly doing their job and doing things that are really nice. They are aware of risks, but they are doing a nice job in trying to mitigate risks of AI. And AI, again, Mark Andreessen just put it nicely, AI is there to help us, not really to destroy us. AI is there to augment our jobs and thinking and reasoning, not really to do nasty things. So there are pros and cons of AI, a lot of them. I will not go through all of these details here, but AI is generally something that can be available 24 hours a day. It can improve human experiences. It can lead to innovation. It can be kind of just judge, whereas people sometimes are not just judges. Ethical and privacy violations, however, on the side of AI are very, very important. We cannot always foresee all the risks that are stemming from AI, even on a larger scale. Just think about applying AI in military applications. That can be very dangerous. So yes, this technology can have pros and cons, but I believe that we should simply look at the right side of it and try as much as we can in order to prevent these risky things. Now, for the last 10 minutes, as I promised to Ganesh when we talked about this talk, I will just show you some more advanced stuff that are very interesting. I'll try to do it in a way that is really digestible by everyone. Even if you don't come from the area of AI, you will be able to follow this. This is machine learning taken as a process. In machine learning, which is a huge part of AI, we start from data gathered from various sources. We have to just transform these data, to clean them, to improve them and make them usable by AI algorithms that then applied on data, they produce what we call a machine learning model. A machine learning model just very roughly can be taken as a piece of software that when fed with other data, not those that are used to produce the model, they can predict things, they can show relationships among things, and so on. And then you can visualize these things so that starting from a machine learning model, you can say there is a good chance that in the elections in the United States next month, this candidate or that candidate will win, or there is a good chance that my favorite cricket team will win on Sunday during the game, and so on. You never have 100% prediction because it's just a certain accuracy. It's usually much lower than that, but with maybe some score larger than 50%. Okay, that's how machine learning works. The most popular tool for machine learning nowadays are neural networks. They start from data at this called input layer, and then they are kind of distributed in multiple layers, these small processing units that are inspired by the idea of neurons in human brain. Starting from input data and input layer, going through multiple hidden inside layers, processing all of these data, we come to the output layer. And we can train, that's the term, we can train this piece of software because neural networks are just computer programs. We can train this piece of software that starting from a certain input data creates some other data. Maybe just recognizes what is the pattern in this input data, but it also can generate something else. Like, for example, starting from, say, a text in English, I can make a translation to Hindi. Or starting from an image of a cat, I can create an image of a deer or a giraffe. That's all possible when you train neural networks to do what you want them to do. Now, how about large language models? They are trained. They are neural networks trained to do all of those tasks like language translation, language or text summarization, or maybe extraction of the essential part of the text from a large text, and so on. How about this example here? If you say that the dog barks, a simple English text, you put it through a neural network, and then the neural network sees the first word first, and then it does some transformation. You come up with the next word with that transformed input from the first word, and this new word, you create yet another transformed piece of data. Then comes the third word. You take this one and the third word. This one actually contains a bit of this one through this line here, and you create something else at the output. That's how people tried to do, say, language translation or language summarization until a couple of years ago, and it was not that successful. On the other hand, if in developing, in actually creating the output, you take all words at all moments, you create this output here with only one word, you feed this word to the next one, you create yet another output, and so on. You have all information about all the input all the time. That's called attention mechanism. Then it turns out that the process of language translation is much more successful. Let me illustrate. You have this sentence here. The animal didn't cross the street because it was too tired. In reality, what happens is that this word, for example, animal, it is more related, more strongly related in this sentence to the word cross, and much more related to the words was and tired than it is related to the word because. This is attention mechanism, connecting words in a sentence, for example, more or less strongly to other words, to all other words in a sentence. If you just dig one layer deeper, you will understand that these are not really words that we are using in this case. We are using tokens, and tokens are similar to words, but not exactly the same. For example, the English word didn't, it has three tokens, didn't, and then this apostrophe sign, and then T. But for example, the word cross, it's just one token. Typically, if you transform the human written text to tokens, you get about 30% more tokens than you have words in the text. But anyway, the large language models are trained with tokens. And these tokens are transformed like words, if you want. They are transformed into numbers. That's called embedding. I'll come back to that a bit later. This is just to show you the idea how that works. With that in mind, we can do language translation with the attention mechanism, starting from tokens and providing all words in a sentence to language translation software at all time. So for example, how was your day? The English sentence here is translated into the French sentence, comment se passe ta journée? And this diagram illustrates what word is more important in each stage. For example, for this French word passe, this previous word is more important than the fourth word here, because passe, that's was in English. The previous word is how is more important in this translation task than the word day. That's what it says. But again, all four words are important. This is just how the network was trained to recognize these importances here. And then if you want to do it in the old-fashioned way, you just encode word by word and get some result decoding again word by word. If you want to do it in a new way, you provide all the words to the encoder, and all these encoded states, encoded numbers, you get here when you are translating. That's the important thing. Now, what actually are large language models? Remember what neural networks look like. Large language models are just bunches of numbers, billions and billions of numbers. Each neuron, each part of the neural network is fed by input, and the input is multiplied by certain coefficients. These coefficients are getting adjusted as we train neural network to do what we want it to do. And these numbers in the end of the training process, they constitute the finalized neural network. In large language models, these coefficients, these weights of the input parameters, huge number of weights because we have a huge neural network, these are large language models. There is no mystery. There is nothing mystifying in there. These numbers are what we have when we talk to ChatGPT or to Gemini or to Claude or to any other large language model. In large language models, we train neural networks, of course, to do useful things for us based on different corpuses. This is the slide that I found recently that shows you how many entities in these corpuses we have. I don't have numbers for all of these different large language models, but for example, if you look at GPT-3, a famous large language models, it had 500 billion tokens taken from different sources. Then again, for example, T5, it had 750 gigabytes of data, again, taken from different corpuses. Whereas, for example, a previous version of GPT-2 that was produced like 10 years ago, it only had the input, the corpus of 8 million web pages, and that's why it wasn't that successful. This is just in order for you to get an idea of how big and how large is every corpus of data that we use to train a neural network. Now, embedding, as I promised, you have data here like text, images, videos, everything. Through the embedding, you are transforming data into numbers, into more precisely vectors of numbers. How are you doing that actually? In the heart of this process is matrix multiplication. Take this very simplified data as an input and take this part of the input, the blue square here. You take the blue square as a matrix, multiply it with specifically designed matrix, and you get a certain number. Then you move this blue square one column to the right. Again, do matrix multiplication, you get a number, another number here, and so on until you move this blue square all over this data input. Eventually, you get some numbers here as the output. Okay? Now, in a realistic example, you have this image here. It is very simplified here in order to illustrate what we want. You have this image here. It can be converted into numbers or vectors of numbers. What neural network sees is this, just numbers. And it is trained to recognize these numbers. It has no idea whatsoever what's on the image. It just knows what the numbers are, and it gets trained on that. And that's how we train, for example, large visual models to recognize images. We provide billions of pictures of human faces. If you look from far away, this looks like a male face with a beard. We provide millions of or billions of such images, and we train the network to recognize, man faces with a beard, whereas in reality, it works only with numbers. How about the latest technology? And this is one of the latest slides that I will show you. There is something called stable diffusion that's currently the most popular algorithm for training neural networks to recognize images and videos, because videos are actually just a long series of images. Take a look at this beautiful little puppy here. That's an image. If you put some noise, random noise over that image and do some adding of noise over the pixels showing the original picture, you get a bit blurred noise. Put some more random noise, the image gets blurred even more, and so on. Do it in about 50 steps. You come here where you can recognize nothing. However, remember that you started from this, doing simple addition, here, 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 all over the place, and eventually you get something that hides the original image. But if you know precisely what was the random noise in this step, and in this step, and in this step, you could actually precisely recreate the original image. But make no mistake, this is random noise. Now, how about trying to subtract random noise from this original image, working backwards? If you just subtract random noise in each step, you probably get something completely unexpected, if anything recognizable. But, and this is what stable diffusion is, but if you train the neural network to recognize patterns in input random noise in each step and apply these patterns when subtracting random noise, then you are likely to get something similar, not exactly the same, but similar to the original image. Okay? And that's called, this first set of steps is called the forward diffusion process, whereas the second set of steps is called reverse diffusion process. And they're all based on this really weird idea, really hallucinogenic idea of training neural network not to recognize images, but to recognize patterns in noise. But most nowadays very successful image recognition works based on stable diffusion. How it works? Let me show you. If you just work from this noise, if you want, that you get in the end after direct steps, you get something akin to original image. But if you provide some textual input to guide this reverse stable diffusion process, you get something which is very likely to look like the original image. Again, if I have the original image with noise, and the original image of an Arctic fox in this example, and I just recreate something, I don't know what I will get. But if I provide a prompt that says, please create or recreate an Arctic fox with this, I may get this or this or this. Whereas in this case, I may get a giraffe or a crocodile. But in this case, I'm getting something, not exactly maybe the same, but something that looks like Arctic fox. Let me finish my presentation with this slide. And you may ask yourself, what is this? What kind of AI is this? Is it generated by AI? No, it's not. It's something that that comes from India. This is a beautiful Indian lady with half of her face covered by her veil, and this is a photo of an existing person. This is for me, in a metaphoric way, this is for me AI. It's beautiful. AI is beautiful. Not as beautiful as this lady here, but it's very beautiful. And this image here reminds me of an old story that I learned many decades ago when I came to India for the first time. I think the story comes from somewhere in West Bengal. I'm not quite sure about that, but I think it comes, or maybe Orissa, or can't tell you for sure. And the story goes on like this. There was a beautiful girl in a village or in a province that was not married. And of course, everybody, all men, they wanted to marry her, but she was refusing them. And then at one point, she said, look, I will marry one of you who kisses me the way that I like the most. And then all of the men came and they kissed this open cheek. Only the wise man, his name was Gopinda, came and kissed this other cheek covered by the veil. And of course, she decided to marry Gopinda, which is a beautiful story. Because if you just come and want to discover what's available and obvious to you, you don't discover the beauty. The beauty is always hidden, like the dark side of the moon. And I think this lady from that story was so very right. And she's the metaphor of all AI nowadays to me. And yes, I wanted to tell you that because this story comes from my beloved India. And thank you very much for having me here to give this talk. This is it. And I'm always happy to come to India. And if we can arrange at any point for me to come and talk to you in person, I'll be very, very happy. Thank you very much.
Thank you so much, Vladan. Thank you so much. It's muted now. Is it okay now? Thank you, Vladan, so much. Thank you very much for your talk. It's been very different, you know. The perspective was very different, and the way you closed is beautiful closing. So, and we also, you know, look forward to having you here in person. And I really appreciate your love, your affection for India. I know that how you are appreciating in Jaipur when we met together. So your family also loves India so much. So we do look forward to having you here on some occasion. There has been some.
The pleasure will be all mine. I would really love to. Definitely.
Yeah, there has been some technical glitches today. Apologies for technical glitches. But otherwise, you know, our colleagues and students attended very sincerely. I think we can have a couple of questions if my colleagues want to ask, and then we'll.
Yes, go ahead. I'm happy to answer them. Yes.
Yeah, somebody. Yeah, go ahead.
Good evening, sir. Myself, Shreya.
Please speak loudly. Loudly, please. Sir.
Are you able to hear me?
Yes, I can hear you, but please, can you come closer to the microphone?
Can you come here?
So in your presentation in NLP and embedding and stable diffusion, so you have talked about random noise. Stable diffusion.
If I understand correctly, you want to know more about stable diffusion and random noise.
Yeah, so you have told us that my question is how to identify the pattern in random noise. You said that we have to check if we want to restructure the image, then we have to identify the pattern in it of a random noise. But it's generated randomly, so I didn't understand it clearly.
Yes, this is actually a fantastic question because when I heard about that, I was also completely confused. But apparently they are adding random noise in about 50 steps, and it is not exactly random, so not totally random. There are some regularities in this random noise. But the point is that in the end, you get some, embedded, if you want, embedded vectors, where there are some similar embeddings for, say, all pictures of, crocodiles, if you want. They all look a bit, not really the same, but a bit similar if they are crocodiles. And they were putting that random noise carefully over these 50 or so the iterations. And then when the neural networks is trained to recognize this noise, actually has some clues of what was hidden. That's my understanding of how it works.
So maybe, let's say we have so many images which is having the same kind of random noise addition. That kind of a data set we should have, then we can identify the pattern. Is it so?
Yes, you can. Look, for example, I will improvise now. See, for example, the background of my room here, this yellow part here. Okay, if you insert random noise in such a way that there are yellow dots here, you don't get much difference. But if you insert random noise with yellow dots here on over my shirt, you do get some difference. This is just an improvised answer now, but I think that these patterns in inserting a random noise are what really qualify this neural network to recognize patterns. Really, that's my understanding.
Any other questions? Anybody else? I have one question. Really, your lecture and talk is very inspiring. I have one question. As AI is broadly classified into two categories, that is narrow AI and that is strong AI. So one is rule based and another is we are not following any rule. That is somewhat ML kind of things we are following. So in which particular
I'm sorry, I can't hear that clearly. You are talking about rule-based something, but I cannot follow. It's noisy.
I'm talking about there are two categories. One is narrow AI and another is strong AI. So in which field nowadays research or upgradation is going on, actually?
Yeah. Okay. You're talking about weak AI and strong AI, right?
Yes.
Okay, good. So my view of this at the moment is that we are still in the era of narrow AI. Maybe we are moving closer to strong AI, but I don't think we have made many steps yet. You know why I'm saying this? If we progressed very much in the realm of strong AI, we would be able to just mimic human thoughts very very closely, which we are not able to do now. What we are doing now, say with large language models, we are just doing some statistics. Try to talk to ChatGPT or whatever. What you get as answers, they're just statistics. Okay, but what if you just ask something completely unpredictable in the middle of a conversation with ChatGPT about, say, poetry, and you suddenly want to ask a question about Mars or Venus? You will get something not that good as in the entire conversation about poetry. Because of statistics, you're suddenly moving to the outlier, and the outlier is not received immediately well. Of course, the conversation will adapt to the new topic over time, but it takes some time. Whereas in human, at the level of humans, you and me can talk about poetry for hours, and I suddenly say, hey, did you know that they sent another satellite to Mars? And you will immediately grasp it. This is the difference. Statistics is not everything. It's a very, very, very powerful tool, true, but it is not everything. There are things that diverge from statistics, and these things belong to really strong AI, not to weak AI. And I think if we manage to have our foundational models do very carefully what they can do in the realm of narrow AI, if they can do it in strong AI, then we are really on a really good trail. But I think we are still far away from it. Although I might be wrong, that's true, because things are advancing with acceleration that nobody could have predicted 2 years ago. But still, there is one other thing that is in the core of my answer to questions like that. All that we do now is done by algorithms. All that we do now is not conscious. There is no artificial consciousness yet. Okay, but without consciousness, we can only do algorithms and statistics and things like that. We cannot do something intentionally. We cannot do something that even little children can do. Let me give you another example. If you need to show 1 billion of pictures of, say, a cat to neural network in order to train it to recognize cats, to me, it is very different from showing 2 or 3 cats only to a little child, 2 years old child, and it will learn forever what the cat is. So we are now using huge statistics in order to do something that conscious human being can do in a split second. Again, I might be wrong. Maybe our brains are really statistics based, but they are just much faster than our current computing machinery. I don't know, but again, only living things have consciousness. Machines don't. Only living things have life. Machines don't. Only living things are capable of doing things intentionally. Machines don't. So, I think it's a philosophical question. We can discuss it for hours, but no, I think we are not that close to the strong AI yet. I'm saying yet. We don't know what comes tomorrow. Or we don't know what comes in the next hour. The things have accelerated so much in the past 2 years that it was never expected. Okay, I hope I at least covered the part of the answer.
Thank you, Vladan. Thank you. We are getting few questions in the chat box also. So we'll not trouble you more. We'll ask only 1 or 2 more questions But before that, I have one question. I go
ahead.
here and deliver talk on brain-computer interface. I'm, using brain-computer interface for analysis of EEG signals for, healthcare applications. So many people ask me that can we build someday exact replica of human brain using artificial intelligence? So it's very difficult to answer whether we can build, exact replica of human brain someday. So I just want to hear from you what would be, what would be, the possible things in this direction.
I know of something that's possible already. There was this piece of news like 1 month ago. There was a person who had trouble talking due to a stroke that they suffered from or something like that. Then they put some electrodes, some wiring carefully into their brain. And that was BCI, that was brain-computer interface. They trained the neural network to recognize the pulses in the person's brain, and the neural network learned how to do it. So the person still cannot talk properly, but that person can express what they want with the help of BCI. That's machine learning applied to help the person with disability in a great way. And the news that I read somewhere on an AI blog did not, was not really detailed, but it was very encouraging, because if we make BCIs cheap enough in order to serve people with such disabilities, that's a great move forward. And I think that's how we should actually direct our AI research, not thinking about the robots destroying human race, but thinking about robots helping human race. And I believe that's doable in a foreseeable future.
Great, thank you. So we are having one question. Yeah, please read the question.
Let me check. Oh, we have some questions here in the chat box.
You can read, yeah.
Yeah, I can read it, yes.
Can you?
Okay. How can we say that there is job loss in the age of AI, even though we know that AI can't match human experience? Oh, yes, we can say that. Again, think about bus drivers. That was a job, still is a job in many countries. However, there are many buses operated by AI, driverless buses, driverless trucks. Truck drivers are getting slowly extincted in advanced countries. Again, in robotically advanced countries like China, there are less and less workers in factories that operate with machines. It's all robots doing it. I myself visited a car factory in Germany several years ago, where they were just assembling cars. And then when I say they, I don't mean humans. It was all done by robots. So yes, robots did replace humans at certain jobs. Yeah, matching human experience, that's a tricky part of your question, because we have to first say, what do we mean by human experience? But look, if by human experience we mean just turning the steering wheel on a truck, can that be replaced? Experience shows that yes, it can. Is it safe enough to sit on a bus driven by AI. Believe it or not, there are studies that show that it is comparatively safer, more safe than sitting on a bus driven by a human. They did some statistics about car accidents that involved buses, and then they showed up that proportionally, of course, the percentages are in favor of driverless buses. So we have to be careful about what do we mean by experience. Okay, let me go to the other question. How recurrent neural networks is able to analyze sequential data? If there is data which is unordered or randomly taken from the source, how will it be classifying? This is a question that reminds me of the old question, how neural networks operate. How do we know that these numbers that are actually coefficients of neural networks, how do we know that they work, that they are doing a good job? And there is no clear-cut answer to that. People were trying and trying and trying. They were developing different configurations, different architectures of neural networks. They were applying different algorithms and different functions in every neuron. Then they came up with convolutional networks, with recurrent networks, with other types of networks. It turned out, after a lot of trying, trial and error, that some architectures did a good job. I'm also quite sure that the idea of attention mechanism that is around since like 6-7 years ago, and that was really a revolutionary idea that brought up transformers and architectures like that. And then there are many other variants of transformers nowadays. I don't think that they were really sure what they were doing. But then somebody came up with that idea. They trained and trained and trained the network, and it turned out to be better than the other configurations. I believe this is that I'm not completely wrong when I'm providing this kind of answer. Be it sequential data or not sequential data, I think you have to be just very careful about what kind of topography and architecture of neural network you select, and you can do a lot, provided, of course, that you have a powerful hardware to train the network. This next question is, I like this one. I wanted to ask if you have heard of Pink Floyd. Yes, of course, I heard of Pink Floyd. I love Pink Floyd. This was on purpose, the title of this talk. Yes, yes, absolutely. Maybe I can make you envy with this answer. I have seen Roger Waters, the leader of Pink Floyd, in concert live 4 times so far. Yeah, of course, I love Pink Floyd. Yes, and Neuralink Corp is working on the PCI. I think we covered that already. As AI in every field nowadays, could you tell us how it will be there in traditional industry in the future? I can try to improvise an answer with a particular example. So a traditional industry, say agriculture. AI will be there, and I believe it's already there. I don't do agriculture, but I know that there is AI there already to use machine learning to produce seeds that are more resistant to pests, definitely. Or, for example, in traditional industry like, say, restaurant keeping and running a restaurant, AI is already there. AI is already there. If you just go to the menu and want to select something to match your personal taste, you will most likely be talking to a chatbot that finds out about your personal taste, matches it with a huge, already pre-trained neural network, and they will prepare a meal for you that matches your own taste. It's already there. How it will replace everything, well, I don't know. I'm not really a prophet and foreseer, but AI is already replacing traditional industries. Okay, I think we've been through all of these questions.
Fine, sir. The questions, rest of the questions, I think, are covered in your speech, answer to them. By this, we would like to now conclude this particular session. We are grateful to have you, sir, and we are grateful for your speech, the time which you have invested. Again, you covered all the like the aspects of AI, right from the basics till the advanced concepts, the latest developments what are being done in AI. So we are really grateful to you. A special thanks to all the attendees for your participation and engagement. Thank you all.
Thank you, Vladan.
And from my side, thank you, my beautiful India. I can hardly wait to come next time.
You love India, so namaste from India.
Namaste to you too. Thank you very much.
Thank you. Thank you. Bye. Thank you so much.
Bye-bye.
Thank you. Bye. Listen.